Okay, let's take a look at Geometry Section 1.5. Segment and angle measurement. Now, much of this section will probably be familiar to you. However, we want to cover it in a little more depth than what you've had in the past. Now, measurement always requires a comparison to an accepted standard. You can't just measure something and come up with your own number. There has to be some kind of a standard that you're measuring against, okay? So because of that, we have what's called a ruler postulate. The ruler postulate says that every point on a line can be placed in a one-to-one correspondence with a real number. Every point on a ruler can be placed in correspondence with a number. Obviously, a ruler has inches on it, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. There are also markings in between those numbers that stand for 1.5, 2.5, 3.5, 4.5, 5.5, etc. And then there are markings in between those numbers that stand for even tenths and twelfths and sixteenths of an inch. 1.1, 1.12, 1.3, 1.79 inches. Every line on that ruler can be placed in a one-to-one correspondence with a real number. The smaller the line, the more precise the number is going to be, the more decimal places it's going to have. Now, the coordinate of a point on a number line is the number that corresponds to that point. That's simple. Above the dash or the line on my number line, there will be a number, 2. That's the coordinate of that spot, that point on the number line. The coordinate of point A is the number A. The point on the number line that corresponds to a number is the graph of the number. What they're saying here is that the number on that number line and the measurement you get when you measure something that comes to that point on the number line, those are the same things. A is A, 2 is 2, 5 is 5. The point on the number line that corresponds to a number is simply what we call the graph, the graphical representation of that number. So, when I talk about the length of line segment AB, I'm talking about the distance between endpoint A and endpoint B on a number line. The way I actually find that distance is I say, where is point A on my number line? I take that number. Where is point B on my number line? I take that number. I subtract the two and find the absolute value. That is the geometrical definition of length. It's the absolute value of the difference from point A to point B. Okay? The absolute value is always going to be greater than or equal to 0 if the number inside the absolute value bars is a positive number. If the number inside the absolute value bars is a negative number, then the absolute value can be less than 0. So a decimal value or a fractional value. Let's look at some examples of length on a number line. We're told to find the length of each segment, BD, AE, and EC. Let's start with BD. Here's B at -5. The coordinate of B is -5. Here's D over here at 2. The coordinate of D is 2. The way I find the length of line segment BD is I write my absolute value bars, and inside the absolute value bars I say -5 minus 2. Well, we know that when numbers have the same sign, we combine them and give it that sign. So I end up looking for the absolute value of -7, which is 7. That becomes the length of line segment BD, 7. let's look at AE. A lies here at -5, -6, -7. A is at coordinate -8. E is down here at 3. I say absolute value bars, -8 minus 3, close the absolute value bars. That ends up being the absolute value of -11, which is +11. Now, what if we were looking for the absolute value of EC? E is at 0.2, C is at -1. I would say the absolute value of 2 minus -1, close the absolute value bars, 2 minus -1 becomes 3, and the absolute value of that is 3. Actually, E is at 3, so it should be 3 minus -1. The absolute value of that combination would be 4. 4 would be the length of line segment EC. Here we have that. E lies at 3, C lies at -1. The absolute value of 3 minus -1 is the absolute value of 4, which is 4. Now notice, the first number we put inside the absolute value bars is the coordinate of the first letter of the line segment we're working with. You're not necessarily working from left to right every time. You're saying what is the origin of this line segment. That number goes first in my formula to find length. Now, congruent segments are segments with equal lengths. If I've got one line segment that's 3 inches and another line segment that's 3 inches, those line segments are congruent. And we use this symbol right here for congruence in geometry. It's an equal sign with a little squiggly line above it. So I can say line segment AB is congruent to line segment CD. I can write all that in geometric shorthand. Let's look at this. AB, well, this is an example where I skipped a slide. Let me go back. Point B is between points A and C. Remember, we write betweenness of points like this, A dash B dash C, to show that B lies between A and C on a line. Now, if AB plus BC equals AC, then that's true. In other words, if I can take this half of the line and this half of the line and add them together and get the whole line, then yes, the point that I said was in the middle is exactly in the middle. Here's an example of that. Find AB, that's this short segment here, and find BC, this short segment here, if the entire line AC has a length of 75. Now, I have no values for A, B, or C, but I do have an algebraic representation of the length of AB and an algebraic representation of the length of BC. So I can say this piece of the line, AB, plus this piece of the line, BC, should equal the entire line, which has a length of 75. So now let me do some substitution. They're telling me that AB is equal to 6x minus 1, and BC is equal to 5x plus 10. So I should be able to say 6x minus 1 plus 5x plus 10 equals 75. I combine like terms and get 11x plus 9 equals 75. I use inverse operation and subtract 9 from both sides, and I get 11x equals 66. I use inverse operation again and divide both sides by 11, and I get x equals 6. Now, that doesn't tell me how long line segment AB or line segment BC is, but it does give me the information that I need to figure that out. I substitute 6 into x's spot and see that 36 minus 1 is the length of line segment AB. That would be 35. And 30 plus 10 is the length of line segment BC. That would be 40. Now let's talk about midpoint. The midpoint of a line segment obviously should come between the other 2 points on the line. I can write that with betweenness of points. And if it's truly the end point, then this half of the line should be equal to the other half of the line, right? The measurement of XM should be equal to the measurement of MY, Or I can say line segment XM is congruent to line segment MY. That's the definition of midpoint. Now, a degree is defined as 1/360th of a complete rotation. That's important to know because we're going to measure angles using protractors. Protractors contain 360 degrees. If you have a complete